bouncing around. Mute everybody. Some movement up there. All right, so this is our second class, but what I normally do is, in a normal class, the first few minutes are devoted to any questions people have specifically, and then I have a few things from the review sections that I want to cover. If nobody has any real topics they want to focus on. And then I have a few things I want to point out that I added in on, maybe there's one thing I added in to the modules on Canvas. So does anybody have any questions or topics that gave you trouble with the practice sections? And hopefully, if you haven't gotten in there and done it, if you haven't done the practice scan yet, all right, this is bad. Do it now, because you should be getting into chapter 1, chapter 2. Those are the review sections. Those should be done soon. I know I gave you some time with the due dates and Canvas, but get on that and get that out the way so you can have questions. So you can ask questions. Are there any questions about anything from those homeworks? And then I'll get into the ones that I want to talk about.
Professor, I have a question.
Yes.
All right. So actually, I did the homework yesterday. I wasn't in the Zoom, but I have a question. How can I submit my work? I already write it down in the paper, but okay. I'm wondering how can I submit it?
Okay. Here we go. You ready? Here we go. Let me share my screen.
Mm-hmm.
So you guys can see Canvas now, right?
Yep.
And the very first announcement I put up back on June 30th.
Oh, yeah.
There's PDF scanning apps, and I asked students to share with me if there's more. And it used to be the first 6 of these I had, and then it grew and grew and grew and grew and grew, and there's going to be more too. So some of these asks for you to pay eventually or something like that. I don't know. I don't care. All I know is they're free to begin with, at least. So you can try one out, see if it works. The practice scan, that assignment is just so I can make sure that what you picked works for me, because I'm the grader. If I can't, I can't grade it. So what you're going to do, you're going to write it on pencil paper. Maybe don't write it on a pencil. That's weird. Using a pencil, you're going to write it on a paper. And then you're going to scan it with one of these apps, or somebody else is doing Google Doc, interesting stuff. Or you could scan it with an actual physical scanner, right? Like a printer scanner thing. You can do it that way too. And then you're going to submit them. Now watch. You ready?
Yeah, ready.
Okay. So here's the practice scan, for example. Let me go be a student. I got to be a student or else you're not going to see. All right, I'm going to pretend to be a student, and then my screen turns all purple. So let me see. Bam. What have I not turned in yet? All right, here we go. Perfect. So here's 1.1 Chapter 1 review. This is an assignment that's in Unit 012. It's the review from Chapter 1. You're going to click this big blue bar, and then you're going to say choose a file. You're going to choose the file, and you're going to say submit assignment, right? Now, if you have multiple scans, you choose a file, and then you add another file, and you add another file, and you add another file until you get the whole assignment turned in. Is anybody not with me on what I'm saying? Let me ask it that way. I don't want everybody to put their thumbs up or something. Is there anybody not with what I'm saying? It's okay if you're not. What's not okay is if you're not and you don't say anything. Okay, I'm going to assume that's a good thing. So everybody understands how work works in this new world we inhabit. Okay.
Thank you, Professor. I got it.
No. Oh, yeah, you're welcome. You're welcome. I don't blame you. I'm getting used to it myself. But we can work through whatever issues you hit. I don't want any technological issues to make it a huge deal. It should be the math. That's the huge deal. They have a question. Somebody just got a text. Somebody has a question. Different. Oh, there's another text. I think it's Brian. Can you explain the difference between a natural and a whole number. I love it. Does anybody know? What's a natural number? One that's not genetically modified. Sorry?
Natural numbers are positive from like 1 to positive infinity. No?
Good. Those are the numbers that came naturally to us. 1 rock, 2 rocks, 3 rocks.
And whole numbers are negative or from negative. Oh no.
No negatives.
They're cardinal, like 0.
Yes, because which number looks like a whole?
0.
0. So I mean that's the easy to remember. Whole numbers adds the idea of 0. Did you guys know that the Babylonian civilization had no concept or no symbol for 0 until right before their civilization fell? It's like, look what I made. Oh wow. Oh shit. We're done. So there were entire civilizations. There were tons of years where humans didn't have a symbol for 0, and then we just take it for granted. So that's one reason why we give these things different names, is to kind of respect the history of how we put them together, right? And then negative numbers came up, and they actually called negative numbers imaginary first. Oh, you know what I'm going to do? You guys, I did want to talk about imaginary numbers today a little bit. And then I got to remember, there's this kick-ass, and I know if geek-ass Jeff says there's a kick-ass video on imaginary numbers, you're all like, that's going to be lots of fun. But this thing, I actually learned a couple things from this video, and I was like, holy shit. So now I try to show it every time I teach imaginary numbers. You guys know imaginary numbers, but I still want to show you this video, or hopefully you do know imaginary numbers. I'm going to make a note to myself. Video. Bam. All right. Did I actually finish that question? Yes. Right? Oh, and Garrett, yes. I'm sorry. Somebody got you on that. Yes. I am recording right now. So, yes. All right, guys. Keep it coming. What else you got? Has anybody tried those Chapter 1, Chapter 2 assignments out yet? Has any of it given you any trouble? Anything not familiar? Oh, all right. Number 70. I was like, is there a problem with the number 70? All right. What is happening with my screen? All right, screw you. Let me see. Bam, ba, bam, bam, ba, bam, bam, bam. Where did I put? There it is. There you go, Jeff. Number 70 in Joshua, which section, which chapter? Chapter 1 or 2? And then Athena, I'll get to yours in a minute. We're actually going to talk about factoring in general later. So let me make a little note to make sure to get your stuff. Chapter 1. Thank you, Joshua. I'm going to share this in a minute. Oh, let me stop this. What are you guys seeing on the screen right now? You still see my canvas?
Yeah.
Textbook.
Oh, some of you guys saw the textbook. Oh, shit. Well, all right.
Now it's you.
I know. You see me. I know. I'll take care of that. Don't worry. So number 70. Whoa, the very last. Oh yeah, dude, this one. I don't even know if Zoom works on this thing. Yes. Could you make the problem smaller? Well, there's that too. Let's see if that works better. Or does that do the same thing? Oh, that's the search thing, Jeff. Good job, buddy. I love it, man. I'm so tired. I saw that and I thought it was a magnifying glass. Is it a magnifying glass? I'm tired. All right, 70 is this one. You guys see that one?
Yeah.
I love it. You're all like, that one. How descriptive, Jeff. I see something. It could be that one. There's a more complicated way to do this, which is kind of the way you do any of these in general. And then there's a quicker way to do this one that somebody did in the homework that I appreciated. What really sucks about this problem is it's what I call fracception, right? It's a fraction within a fraction. And nobody's doing the little, I'm so tired, I forgot what the hell you call it. What do you spin, the spinny thing? All right. The top. Nobody's spinning the top. All right, pretty good.
You mean the reciprocal?
Sure. Yeah, but that's the quick way that somebody did. What I was talking there was a stupid reference to a silly movie that I need to watch again with a notebook. So there's a longer way that involves getting an LCD on the top and then doing some stuff. But the shorter way is to multiply top and bottom by the reciprocal, right? But eventually you're going to need to do the LCD anyway. So remind me, who asked that question? Or did you try something? Who asked that question again? I forgot. My chat is gone. Joshua. Did you try anything? No. Okay. So you could focus on the top and get those put together. What will the LCD be for the ones on the top?
XY.
Yes. One's got an X, one's got a Y. The only way they can agree is if you give them both an XY. So the first guy's missing a Y, the second guy's missing an X, right? And then you can put those together, and then you got a fraction divided by a fraction. So then you just multiply by the by the reciprocal. Is that all right? And when you divide fractions, you multiply by the reciprocal. Is that all right? Or do you want me to? I don't want to necessarily do that problem for you, but let me see.
So would you recommend finding the lowest common denominator on the top first before you flip the denominator, or does it matter which way that you do it?
I'm going to make a problem like that. All right, I'm sorry. So, yeah, you're right. There's multiple ways to do this problem. You're going to do it. There you go. All right. I'm just a big microphone away from being a YouTuber. Okay. So this is sort of like the problem in the book, right? So the top, this guy's missing, what's this guy missing? Just looking at the top problem.
MB.
Missing a B. This guy's missing
M.
Yep. So then you can combine the top to be 5b minus 2m over bm. And division by 6 over b is multiplication by b over 6. Is that all right? I probably should have picked the number 6 because they look like my b's. You guys are right. And then, of course, the b's cancel, and then you're basically done. You just combine those together. You just multiply those. Is that all right? There are other ways to do the problem, different orders to do that same math work, but you end up doing the same math, just at different points. Is that all right with everybody? You guys all right? Are you guys okay?
It's good to go.
Oh, we all died.
Oh, man. Well, I'm glad right before you died, you logged in. Sorry. That was very strange timing. Let me log it. All right. Just my luck, somebody's probably actually dead out there. Can you show us the, oh, wait, I skipped somebody. Factoring a polynomial with, oh, good, I love it. Actually, I just realized what you're saying. You don't mean a factorial exponent. You don't want a factorial exponent. Do you guys know what factorials are? Oh, I see, you correct yourself, Athena. I'm sorry. I'm not going to mess with you. Factorial would be really intriguing. So I got 2 questions on number 58. I love it. And I think I know what 58 is. Let's see if I'm right. Yes. Yes. Where'd he go? Look at you, Jeff. Knowing how numbers work and shit. All right. So watch this. I'm going to start off with an easier problem. But then I'm actually going to follow it with a harder problem. So don't give me crap about starting with an easier one. How would you do this?
Are you doing it on the whiteboard?
Oh, shit, I am. And I'm sharing, aren't I?
You're sharing the textbook. Yeah.
Okay. You got to remind me about that. I'll forget that I'm sharing. It's just,
okay.
Don't take it personal. But just thank you. 4x minus 7x to the 3rd power. How would you factor that?
You'd factor out the x, right?
That's insane. Yes, you're right. Why wouldn't you factor out an x to the 3rd power? Why wouldn't you factor out the larger power?
Because there's only one x on the other.
Yeah, because the other dude can only give 1, right? So if you try to take 3 from him, he's going to freak out. So what does that have to do with anything, Jeff? I don't know. So what about this? I actually made a problem. You can do it, Jeff. All right. That one's getting closer to the one in the book. Let me take this away so nobody freaks out. So what was the general idea we just discussed? You take out the smallest power on the variable that you see, right? So what's the smallest power that I see in this expression?
X to the negative 3/4.
So you take out an x to the negative 3/4. And just to remind you guys, I can't remember what the hell it was up here, but let me just put this up here. If I took out an x squared, wouldn't that make that 1, of course? And when I subtract 5 minus 2, and I love you guys, and then of course you can do further, but screw it. Right, you're all like, yay, Jeff, 5 minus 2 is indeed, and if you saw it, you could like agree with me. There you go. All right, there's a purpose to my saying that. I'm taking out a negative 3/4 power, so of course this is going to be 1 minus 2. What's 1/4 minus negative 3/4? 1/4 minus negative 3/4, because that's what I'm taking out.
Just 1.
1.
Yeah. So what you do doesn't change. We're just not used to seeing fractions and negatives, but the actual process, I teach this kind of thing a lot. The process doesn't change, but the parts that are in there changes, right? But the basic idea doesn't change. That should help you with the actual problems you have to do. They're slightly more complicated, but not that much. Is that all right for number 58 kind of stuff? No? It's okay if it's not. You just got to tell me. Okay. All right. That's interesting. So that's one of the things I was going to talk about. So which means I don't have to worry. Well, maybe I do have to worry about this still. I'll talk about that still. Okay. What else you got? Anybody else have a question about anything from 1 and 2 or? I love you guys. I operate, so it's okay. I'm not saying your job is to come at me with questions, but I love questions. You're going to ask me if there's ever something that you've ever done in math and you don't know why the hell it's done that way. Now is the time to ask. Okay. So there's a couple other things I wanted to ask you. One of them is just to remember what this means by itself. How would you do this? How would you simplify that? I think we saw one like that yesterday. Yeah, good. So remember what I said, the roots are on the bottom, powers on the top. But what does this mean?
Would you flip it and make it 1/8 to the 2/3?
I love it. Which is 1 over the cube root of 8 squared. And of course, cube root of 8 is 2, squared is 4. Yay! I like it. Okay, just to make sure, since there was a question about fractional exponent kind of problem, I want to remember what the fractional exponents themselves meant. I like it. Real quick, just go with me. What's this?
7.
7.
Yes. Because anything to the 0 power is 1. I like it. Okay. Bodacious. All right, something else. So anytime you have a question that comes to mind, please feel free to ask. All right? I've got a couple more things I want to talk about in general. And then I'm going to go through each chapter 1, chapter 2 kind of stuff to make sure we're cool with it before we move on. What does this represent?
The square root
Imaginary numbers?
Yes, imaginary numbers. And specifically, it's the square root of...
Negative 1.
All right, now, have you ever seen have you ever seen this idea here? Multiplying by -1 is a 180-degree turn. If I multiply by -1, I rotate by 180 degrees. Do you guys see what that is? Do you guys get that?
Yeah.
And this is, I actually use this in my Math 88, not to talk about imaginary numbers, but to explain why negative is positive, because I rotate and then I rotate, so of course they cancel each other. Now, what if I multiplied by half of -1? So this is multiplied by -1. What if I multiplied by half of -1? How far should I rotate? If I multiply by -1, I rotate 180 degrees.
90.
Yeah, 90. So I'd stop here. So what the hell's here? Just stay with me. I know you guys. Sorry?
Is it 0?
Nope. So we're on what's called the lateral axis. This is the I-axis. So this is multiplying by the square root of -1. Because what do I get if I multiply by another square root of -1? Don't I just, I'm supposed to get here now, right? If I multiply by another square root of -1, I have to do another 90-degree turn, so I should end up here. Are you guys with me at all? Is everybody cool with multiply by -1 as like a 180-degree turn?
Yes.
If everybody's cool with that, you must be with multiplying by half of -1. Square root of -1 is a 90-degree turn. So if I do square root of -1 and then another square root of -1, what is that?
-1.
-1. So sure enough, a 90 and a 90 makes a 180, which is -1 like we're used to. Have any of you guys ever heard imaginary numbers explained like this?
No.
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 And then I could ask you, do you like them explained like this? But I'm not going to. Don't answer. All right. So here's the thing about imaginary numbers. Does anybody remember the idea? You can do it, Jeff. Can you count? There you go, buddy. Do you guys remember the cyclical pattern of imaginary numbers? Any?
Yes.
You look? Yes. Okay, cool. Watch how that fits in nicely here. So this is I. This is I squared. Let me replace those. This is I. I squared is -1. So what happens if I go another I cubed? What would be this?
-I.
-I, and that's exactly what it is. And what if I do another one?
+1.
I'll get back to 1. So I to the 5th is going to be I again. And so on forever. Ad infinitum. Does that list sound familiar to anybody?
Yes.
Yes.
Does that picture actually make more sense? To be honest, I don't know.
Yes. Very much so.
You haven't made any sense yet at all. I'm like, all right. But the funny thing is, I mean, this is the complete picture. And all right, you got to stay with me. When they first discovered negative numbers, they called them imaginary because people were like, how can you have -3 apples, Steve? Get out of here. I don't know who Steve was, but I'm sure he's some guy talking about negative numbers. Eventually, they came to accept negative numbers. Then what we call imaginary numbers were conceived of, and unfortunately, that name stuck around just long enough that we couldn't change it. They should have been called, let me see if you guys get this. They should have been called lateral numbers. Because where do they exist? To the side of the real numbers. All right. Okay. So about 4 people, I think, are definitely still with me. All right. So that's imaginary number stuff. So you got to know that. So can anybody tell me what this is? That's you erasing. What is this? Hopefully you can see that all right. My lighting situation is always questionable.
Is it 1?
How would you know? What'd you do?
1.
Wait, am I right?
I don't know yet. Actually, I do, but I want to know what you did.
I think it would be -1 because 74 is like divisible by 2. So I was just saying if you keep going to the.
All right, so one way to do this is I squared to the what?
32?
30.
36. Oh.
You can do it.
Oh.
And then I squared is, and since there's an odd number of -1s, then the answer is -1. Right? No? The other way to do this, that's fine with me. But the other way to kind of use this cyclical nature is to say 4 goes into 74. What is it? 18 times? Remainder 2. Do you guys see what I'm saying? So
Yes.
it's this cycle 18 times, remainder 2. So this is the same thing as I squared, which is -1, which is what I got there. So anything that's cyclical in nature has to be simple to use, because that's exactly what this is. It's all about cycles, patterns, cycles, all that kind of stuff. So if I see a cyclical pattern happening, I should be able to mathematically determine whatever I want to, wherever I am in that process, in that sequence. Okay, maybe. Are you guys? I hate not being able to see all of your faces, but if you
mind blown. Good job.
Well, oh, okay, sure. Okay, that's a positive review. Okay, thank you.
What do you call that symbol?
Which symbol?
The upside down question mark.
Oh, dude, that's an I.
Oh, it's just I. Okay, got it. Okay.
That's my overexcited. Instead of doing this, I have a little curve on it.
Okay, got it.
Does that mean that if it's not an odd number,
Yes.
it will be...
So if it was I to the 40th, well, that's, yeah. I mean, here's an example. I to the 40th, if you want to do it this way, it's I squared to the 20th. Become a 20, Jeff. There you go, buddy. -1 to the 20th, and that's 1. Because any even pair of -1s kill each other, so there's no odd negative left over. But if you do it this way, 4 goes into 40 evenly, no remainder, so it's 1. Because it went through the cycle and stopped here. All right.
Do they ever do I to the negative exponent?
Hell yes. So what would that be? I love this. I love it. See, this is the shit I live for. Sorry. So what would that mean? Like, what would I to the -3 be? You know what it is. And you're like, what do you mean I know what it is? You do. What's a negative power mean?
The reciprocal.
Yeah. And then what's I cubed?
Negative. Oh, I.
Good. And then what's wrong with this? Does anybody know what's wrong with this?
You can't
You can't have a negative underneath.
No, negative is, I mean, you have to put the negative up there, then who cares?
You can't have I on the bottom.
Good, because I is fundamentally a root. And that's the last step to do, is to simplify something so there's no root on the bottom. Are you guys with me?
Yes.
How do I cancel that out? Let me leave this down here.
You multiply I to the top and the bottom?
Good. That would be the complex conjugate. Does that sound familiar at all?
Yeah. Yes.
Okay.
Yep.
And then so on the top again, I, and what's I times I?
-1.
And then -1 is 1. So then this is just I. Now, if you did a few more of these negative powers, you might see a pattern there also, right? You might expect there would be a pattern of some kind, right? Maybe? No? Now, what gets really freaky, which we're not going to do too much of, is what about like the square root of I? Here's one you could do. Square root of I is definitely weird. But here's one we can do right now. What's the cube root of I? Let me be even nicer. What's the cube root of -I? And I love it. You're all like, did he say we could do that shit? Yeah. What's the cube root asking you? What do you cube to make the inside? Go ahead.
Is it just I?
Yep. Because what's I cubed?
Negative I.
Yep. So that one you can get kind of not really cheating, but it doesn't feel satisfactory, right? Like you didn't really apply the root. You just sort of remembered. So it's a more interesting question would be, what's the square root of I? And you can realize, holy shit, that's a different ballgame. We can still deal with it. We just haven't written it in a format that we know what to do with it yet. Yeah, maybe. Okay. All right. So anything about imaginary numbers before there is one more thing I wanted to say about imaginary numbers before I keep going. How would you do this? How would you simplify that?
You would multiply by the conjugate of 2 minus 3i.
I was hoping that since we had just talked about conjugate, now this is a real conjugate, right? It's got both the real part and the imaginary part. So you'd multiply by 2 plus 3i. Can anybody tell me, in a very succinct way, why we multiply by the same thing with a plus in the middle or a different sign in the middle?
Isn't it so you can cross
To
out?
cancel it out.
Because now it becomes what I call a difference of squares pair, right? The middle term cancels, and the middle term is the only place there could still be an imaginary piece. So when I multiply by a conjugate, it makes it real. Shit, just got real. So on the top, I'll do the top. Oh man, I'm tired. All right, you guys do the bottom real quick. There's somebody whistling. I'm gonna mute everybody.
So we don't cancel them out since they're both like positive and negative?
We're not adding them, right? We're multiplying them.
Oh yeah. True.
Even if we were adding them, only one of them has a different sign.
Correct.
Okay. So I'm glad you brought that up, because sometimes some people just don't write a bottom at all, but there is going to be stuff here, right? 2 times 2 is 4. Then you get the 6i minus 6i cancels. Negative 3 times 3 is negative 9. I times I is negative 1. Are you guys with me?
Yes.
So then you end up with plus 9, right? Minus 9 times negative 1 is positive 9. So then you get, and I'm fine with this, but you could go one more step, which is sort of like the official way to write a complex number, right? A plus bi. Does that sound familiar? Now, I just want to remind you guys real quick, in case anybody out there sitting there going, what have I done to myself? If it has been a while since you took math, it is okay to ask questions and say, I forgot all this shit. This is the time to do that for me and for all the other people that are sitting there being quiet and afraid to ask questions. Don't assume everybody understands everything that's going on, because that ain't true.
Why is it plus 9 and not minus 9?
I love it. So let me step through that. So 2 times 2 is 4. Then I get the plus 6i minus 6i. That cancels, right? Then I get, let me just go ahead and do this all the way out. Negative 3i times 3i is negative 9i squared. Is that cool?
No, so you flip it, right?
So what's I squared?
1.
No, I'm sorry. No.
Negative 1.
Negative 1.
So that's negative 1. So you get 10 plus 15i over 4 minus 9 times negative 1, which leads you to 4 plus 9, which leads you to 13. Is that cool?
Okay, yeah, got it. Thanks.
I like it a lot.
Is this in chapter 1 or this in chapter 2?
This is in, oh shoot. I am very bad about, I talk about concepts and I have no idea where the hell it is. Are you kidding me? Let me see. Where do they talk about complex numbers? I think it is chapter, I thought it was chapter 1. It might be, there it is, chapter 2, section 2.4.
Okay, thank you.
I'm sorry, go ahead.
I just said thank you.
Oh, okay. I only assign problems out of the review exercises, but you can definitely go back into each section. Anything that really gives you trouble, and at least read through it, look at the examples. You could do some problems from there, maybe the odd ones so you can check the answers. That's on you to get ready for this course. A lot of my colleagues just skip chapter 1 and 2. And I don't know if anybody out there is just wishing I had done that, but I always thought that was so evil. I don't know. What do I know? All right. Anything else about imaginary numbers before I leave that concept behind?
Okay, yes, hold on. The earlier question we did, okay, negative I, one of the last ones we did, okay, the cube root of negative I.
Oh, yeah. So
that you said that equals just I, correct?
What is I cubed?
Is negative I.
So what's the cube root of negative I? It's got to be I. Isn't that how roots and powers work? So watch this, you ready? If I told you that W squared equals capital A, what's the square root of capital A?
W.
W. I mean, that's assuming everything's positive. I don't want to bring all that shit in there, but you guys, that's how inverse functions operate. And real quick, since I just said inverse, why are these not really inverses of each other? I just kind of gave a, what do you call it, Jeff? You could do it. An example just now. For example, if I said that W squared equals 9, is there one answer to that?
No.
No.
There's two, the plus and minus. So therefore, there's no inverse function because there's two possible outcomes. Does that sound familiar? Horizontal line test?
Yeah.
Yeah. Okay. All right, sorry. So there's a lot of tangents that go on in this review section. Once we get into chapter 3, it'll be much more methodical. 1 and 2 is kind of like a review stuff. So I could, if I say something and it leads me somewhere, I think you kind of hopefully see what I'm saying. Any other specific questions about complex numbers before we move on? Okay. So let me do this. I want to show you. Yeah, good. I want to show you something I put up on Canvas. Oh. Let me see. I tell you what. It's just a cruel joke to have a cold in the time of COVID. All right. Can I do this now? I don't know what has happened to you. Okay, there we go. There we go. Oh, this is the most exciting thing in the world for you, right? Watching your professor try to figure out the technology. Okay, so let me share this. This one, share. Go to 176. And what I've added at the very bottom of unit 0 and 2, I put a factoring methods sheet. Factoring is going to be huge. Huge. This is something I give out when I first teach factoring, but at the very top of the sheet, it's kind of like a quick reference guide. You know, like GCF, you try grouping, trial and error, Surefire. I call it Surefire, by the way. I have no idea what you guys, master product is what it's called also. Diamond method, whatever the hell. And then differences, squares, or cubes. So there's examples of each. There's kind of like an explanation of why it works, an example of each. And then I have this side that if you want to, we can try some of these out. And again, I kind of base things more on questions you want to investigate. So, especially in the review section. So are there any of these that look intriguing that you might want to try right now? Let me do it this way. Can you guys copy down the first 3 there? Everybody can see that?
Yeah.
Jeez, Jeff. There you go, buddy. Maybe bring the whole thing up. Yay, Jeff. Copy the first 3 down real quick for me. Copy them down. And then try to do them. And then I'm going to break you out into rooms. It's some people's just favorite thing for me to do. And just double check each other's answers. If you were here yesterday, we talked about the cubes one. And we did talk about number 2 also. And number 1 should not be a problem, but we'll see.
I'm actually on the module trying to open up the factoring methods, and it doesn't allow me to open it up.
What's it say?
It says factoring methods, but there's nothing to it. When you try to click on it, nothing happens. It just highlights factoring methods. Nothing comes up. Doesn't go anywhere.
Is anybody else trying to open it? That'll suck if it doesn't work.
Yeah, mine doesn't open either.
No? What the shit?
Actually, mine is not working either.
You don't have this link right here?
I think you have to click done on the 1.1 chapter review.
Oh, you guys are funny. All right, thank you. I didn't want to assume this about anybody. It is at the very bottom. Let me do this. Once I do this, now it's in a different place. Now refresh your canvas. Just in case you're somebody who hasn't gotten through with Unit 0 yet. That's a good point. Thank you. I forgot about that. So
Perfect.
now,
Thank you.
refresh your canvas. Yeah. So that's my fault. I made you step through that first module. So, okay. That freaked me out. I was like, please tell me it's going to work. Holy shit. Let me open that back up. I'm sorry. Here we go. Yay. All right, give those a quick try. I love looking at Joshua's profile picture. I love it. Sorry. Okay. Has everybody got those written down?
Yep.
Yes.
Yes, okay. So I'm going to break you out into groups real quick. I'm not going to come in there unless you call me in. And when you go into the breakout rooms, did everybody notice how to call me in? There's a link at the bottom of the screen when you go into a breakout room. You can call for me to come in. But
yeah, the help button, right?
All right, go ahead.
The help button, right?
Yes, exactly.
Yeah.
I'm just going to give you a few minutes, though, to work on these 3. So let me do this. Let's see, I got 37. That's a beautifully not even number. Let me put, sure, 10 rooms. All right, so when it comes up, go ahead and click on it now. Go away. Go. Fly. Run, you fools. Who's still out there? This is when I can find out who's actually here and who's not here. Okay. Okay. If anybody can still hear me, there we go. So Dalton and Vanessa, there should be a link on the screen to click to go to the breakout room. Hey, and now we're just stuck with Dalton. Dalton! Are you out there, man? Hello? Dalton? I guess I don't have to record that. You're being watched. Let's see. So the very first one hopefully wasn't a problem, right? So who's got that one?
X plus 9 times x minus 9?
Yes.
Yeah. Cut them in half, minus plus, so that the middle terms cancel. Bodacious. By the way, let me ask you this. I'm going to do one. Why don't you use numbers, Jeff? Because I think, don't I use numbers? Yes. Here's 1A. All right. How would you do this? What do you got, Jeff? Something gross. Yeah. Something so gross. How is that different from this problem? Is it different from that problem?
It has more letters.
Good, that's it. Otherwise, they're exactly the same problem. I go one step further. I say they're the same problem. This problem, what did I have to do? I had to cut everything in half, put a minus plus. What do I do on this problem? Cut everything in half, minus plus. Why do I do that? There's two terms. Everything is something squared. Therefore, it's a difference of squares. Therefore, the process don't give a shit what it looks like. It works. Somebody is saying no to me. Uh-oh. I'm not sure what that means. All right. Is everybody okay with what I just said? Anybody not okay with what I just said?
I didn't understand what you just said.
Okay, let me try again. So why was this one so easy? Because everything is a square, and there's a minus in the middle. So therefore, it's difference of squares, which is relatively easy, right?
Mm-hmm.
So what's going on here? It's a difference, and everything is squared, is something squared. Do you see that?
Oh, yeah, I see.
Therefore, it must be just as easy. It's only going to take longer to write, but who gives a shit? Do you see what I'm saying?
Yeah.
How would you take the square root of 810? 8 to the 10th power. 8 to the 10th power. How would you take the square root of that?
No. So don't think of it like that, but that is what you're doing, but you're cutting everything in half multiplicatively. So 16 is 4 and 4. Cut A10 in half. Do it. Cut A10 in half.
A5? 8 to the 5th power?
Keep going. Because now watch. Let me see if you guys are with me. There is no number 10 anywhere in this problem. Nowhere in that problem is there a number 10. Does anybody think I'm insane?
No. Because when you multiply them, the exponents add. They don't multiply.
Exactly. So this is
okay.
When you root things with exponents, the exponents actually act like subtraction. They act like division in this case, divided by 2, because a square root is a 1/2 power. So it actually cuts exponents in half. I like it. So there is no 10. There are 10 A's, but I'm not doing the square root of 10. There is no 10. There is no spoon. So this would be b to the
1.
Well, sorry.
Oh, to 10, sorry, 10.
C to the 19. So the same thing here. Did I give myself enough room? Probably not. 7W 50, right? And Z 26 plus 7W 50 Z 26. Okay, that's just a lot of writing, but did the idea change? No. So much of math is just like that. I look at it like Yoda math. Small I am. Right, so if it's small, you say easy. If it's big, you say hard. That's crazy. That's still just as easy. It's just a little bit longer to write. Maybe?
Yes.
Okay. Don't judge me on my Yoda impersonation. I don't care. Seagulls, stop it now. All right, so let me see. What about, oh shit, how do I get there? Sorry. You can do it, Jeff. There it is. All right, the next one, I had a group call me in to talk about this one. What's the first step on part B?
Find AC.
Good. AC is the AC method that kicks so much ass. I call it the Surefire Method because that's what my teacher called it. I am a Georgia boy, but I didn't learn this in Georgia, although it sounds like a very Georgia. Surefire, it's going to work. So like you said, you take the A coefficient, the C, you multiply them to get 72, and you try to find factors of this that add to be that.
Negative 36, -2.
Yeah. Okay. Sometimes it's easier to start with what adds to be this, and then check to see what multiplies to be that. Let me mute everybody. So now I can rewrite the middle. And it doesn't really matter what order you put those two numbers in. And now I've got 4 terms, so I can group. Right, so I'm just going to kind of do this. Let me know if you have any questions. Out of this, I can take a 4x. That's a -2x plus 9. I want it to be opposite sign, so I take a -1 out. And since these are the same, I can do the last step, which is take those out. So then I'm left with 4x minus 1. I'm hoping that sounds vaguely familiar.
So you divided the 8 and the 36 by 4.
Yes.
Okay.
Because that's the base number that goes in both. And I could use this as a clue. I'm like, nothing comes out of there, so I have to make that a 2, so I got to take a 4 out. Because I know that these have to be the same. So there are clues in the problem itself, which is always appreciated.
Mr. or Professor, I did instead of 8x minus 36x, I did 8x squared minus 2x. And
Yes.
then -36x plus.
Wasn't your 4x minus 1 in here?
Yes. I got x minus 1/4 though, because I took out like the actual 8 from.
In weirdness. Okay. No need to make any fractions. In fact, you shouldn't.
Oh.
Yeah. Normally, we consider factoring to be over the integers, but sometimes we do more than that.
So if we had, if we did 8x squared minus 2x minus 36x plus 9, and we got the same answer, just like flipped,
Yeah,
it would still be correct, right?
These don't matter what order they're in. So if you did do 8x squared minus 2x minus 6x plus 9, just to do this real quick, you can put that. See how the 4x minus 1 is inside, whereas out here it was outside? 2x minus 1 here was in, but the last step is going to agree, right?
Yeah, okay, thank you.
All right, so let's take a look at that last one. And this is everybody's favorite, normally. What movie relates to this problem somehow? Anybody?
Pulp Fiction.
Pulp Fiction. I love it. You're like, let me just say this to make him happy. I'm sorry. So the way I think about this is obviously a cubes, 2 terms. Everything is something cubed. This is A, and this is 2, 2, 2. So when you see that, you automatically put down a little dude and a big dude. Little dude, big dude. And the little dude is just a little dude. Little dude, you can only take one of each. So 1A and 1, 2. Same sign. So the other 2A's go here to make A cubed. The other 2 2's go here to make 8. But then you get all this other shit you don't want. So this has got to be the opposite sign. This times this, whatever they are. Done. And there's one thing I didn't show you that I almost don't like this, but I'm going to show you anyway. This one is always the same sign This one's always the opposite sign because his job is to kill the shit you don't want. So of course he's going to be the opposite sign. And this one is always positive. So you see how that goes along with my Pulp Fiction. What did they have to use to clean things up? A lot of soap. So, I mean, that works still.
Quick question.
Sure.
What if it's like a cubed minus 8?
Oh, if it would have been, let me see if you guys are cool with this. Ooh, I can use red. Watch out. If this would have been minus, this would have been minus because it's supposed to be the same sign, right? And this would have been plus because it's supposed to be the opposite. Otherwise, everything's the same.
Oh, okay.
What about this? Can you factor this?
X minus 5x plus 5.
Test it. Does it work?
Is it x negative 5 and x positive 5?
Does that work? What's
No.
negative 5 times 5?
Negative 25.
Negative 25.
Not positive. Oh, shit. So technically, you can't do this. Let me give this away. So everybody see why you can't do it? The reason you can't do that is the same reason you can do a minus. The minus allows for these to be opposite signs, which allows for the middle terms to cancel. Right? So I appreciate you guys trying to force them to be opposite signs. They have to be, but then you end up with a negative. What kind of number, though, can you use to actually do this?
Imaginary.
Imaginary. So if I would have done this instead, that works. Maybe? Are you guys okay with that? So
Yeah. I don't get how that works. Can you explain it, please?
all right, so watch. I'll give it to you a different way. So this is not an equation right now, is it? But if it were an equation, how would you solve this equation right here?
Add the 25 to both sides.
Well, subtract. I'm with you.
Subtract, sorry.
Take a square root, right?
And that would give 5i.
Yeah, that'll be plus or minus 5i, which goes right along with those.
Okay, I get it.
You need two numbers that multiply to be positive 25 and add to be 0 because you want the middle terms to cancel. And the only way you can do that is with complex numbers.
I see.
I like it. Coolness. What was that? I think that might have been. What time we got? You guys are okay if we leave early, right? What time is it?
Of course.
Well, sometimes I actually have had people ask, "Go, I'm paying for it, man. I'm paying your money." What do you like? So if you are upset with me, I'm sorry. File a report. Let's leave a little bit early tonight. I mean, normally we leave at 6:50, so it's not like a crazy amount of time. I got as far as I really wanted to, and since nobody had a lot of questions, then we have a little extra time. So desperately, I need you, and you need you to come tomorrow with questions, right?
Sure. Sure.
You've got to get into chapter 1 and chapter 2 if you haven't done that yet, so that you can have questions to ask.
Okay.
Does everybody know when the quiz is on chapter 1 and 2?
Monday.
Say again?
Isn't it on Monday?
It's on the 24th. Is that Monday? Yes.
Yeah,
All right. I can't know both things at the same time. It's sort of like you can't know momentum and position. Yes. So on the Monday, we're going to have a quiz on these two. So that's plenty of time for you to get done with the homework. But the sooner you get done with the homework, the more time you have for questions, the more time you have to do corrections if you have to correct the homework.
I have a question about turning in the homework.
Yes.
So if we turn it in and we have corrections to make, do we just turn in whatever, like the questions we just corrected?
Beautiful. So you only have to correct the problems that I marked as wrong. And then when you scan it, you send it in the same exact place, like on top of the old one. I'll be able to see both, but you'll only be able to see the like most recent submission. So I'll grade
Okay.
your corrections and then yeah. Does everybody
I
know?
have a question.
Sorry. You can go.
Oh no, go ahead.
Okay. So I did that. I like sent in my corrections and it still came out like as incomplete. Does that mean I still have to keep correcting? Like
You get one shot at correction. So who am I talking to right now?
Jackie, Raina.
Let me make sure that this is true.
It was for the 0.1 or 1.1 review.
All right, 1.1, I got you. While I'm looking that up, anybody else, is that clear for everybody else how the corrections are going to work?
So when we turn in corrections, is it fine to, like, if you mark 2 for correction, is it fine if we just turn in those 2 questions, or do you want us to turn in, like, the whole page again?
That's just what I asked.
Oh, yeah, you only have to turn in the problems you got wrong.
Yeah, okay.
Oh, and you don't have to give me the original because I've got that.
Okay.
So when you resubmit it, on your end, it looks like it overwrites it. On my end, I can see everything you've ever turned in, right? So I'm okay with it. And Jackie, I'm guessing, I appreciate you asking me this question. I'm sorry it's got to be kind of like your dirty laundry aired out, but yes, I think it looks like what happened is you still had a few too many mistakes. So you can still ask me about it.
Oh, okay.
So, and it's not going to kill you, but I only give one shot at homework corrections because otherwise I would go very insane.
Okay.
This is not like English class where you have a 5th draft. So you want to, and the homework corrections, anyone know when the homework corrections are due?
No, the
Saturday?
day of the test or exam. Or
Which
quiz
test?
or something.
No.
I don't know, the chapter quiz.
Day of the final.
Day of the final. There's somebody who watched the syllabus video. So you have plenty of time to work. And I understand the mentality of wanting to get it done so you can check it off. So if you do it quickly, you might have to live with the fact that, and by the way, just so you know, if you're in a situation where you turn in corrections and it's still not good, that means that those are half credit. So everybody right now has 100 homework average, and as you don't turn something in or you get half credit on something, it goes down from there. You guys with me?
Yeah.
And I like it. And homework grade is a part of the quiz average. So the homework average, the homework percentage is lower than you might think. Perfect world, I would make it 0, but I can't make it 0 because the one time I tried to do that, nobody did homework and they all died on the first test. That was my 2nd semester teaching, and I learned very quickly.
I have a question.
So tonight, go ahead.
Emily.
So do you care if the homework is handwritten or would you rather it be typed up?
Oh, I would rather handwritten, please. Thank you.
Okay. Gotcha.
Question.
Yes.
So tonight's homework is chapter review, right? Chapter 2 review.
So here's let me look it up real quick.
Because it says right there the 18 and 19 for the homework / timeline sheet.
Oh, okay. You ready?
Because I'm looking at that, and then I'm looking at the module.
I got you, dude. Hold on. So in the assignments, or I'm sorry, let me do it the way you'll see it. In the module, you'll see due dates. See how chapter 1 review is due August 22nd. And so is chapter 2 review, August 22nd. And I think the 22nd is, it says Saturday. And the reason I did that is I know some people can't work on stuff until the weekend, but I want to give myself enough time to look them over on Sunday, so then you could look at them Sunday night to review before the quiz on Monday. There's a method to my madness. What you're looking at is the dates that I think will be in the chapters. So the dates that show up here,
okay.
These are not due dates. These are when I think will be in these chapters. So I gave us 3 days to go over the chapter 1, chapter 2, to do questions and all that kind of stuff.
Yeah, bet. Makes sense now.
I like it. Thank you.
That's and then,
question. I mean, yeah. Go ahead.
And then also, before you can unlock chapter 1 and chapter 2 review, you need to do the practice scan, correct?
That's right.
Okay.
And of course, on my end, it makes sense because that's how I make sure that this app or whatever method you're using ends up with a good result on my side.
Okay.
So I want you to turn work in, and I can't even see what it means. That's yeah.
Yeah, because I was a little lost, but I was like, oh, okay. Now that explains it all.
I like it. I can see clearly now. Yes, sorry.
I have a question.
Yes.
Do you have like a remind or no?
I think I've heard. Okay, Remind is an app, right?
Yeah.
Okay, somebody showed me that recently. I've got all these apps now to look into. I didn't want to use. This one teacher uses like 8 apps, and I'm thinking no. But that one is the one that I can't remember what that one does. There's one that I could do almost like Google Voice does, and like have a text with students, and nobody really knows anybody's phone number.
Yeah, I think that is Remind.
Is that Remind? Okay. So yeah, I've heard of it, but I just haven't looked into it enough because I heard about it like a week and a half ago.
Oh.
And I just haven't looked into it enough to really buy into it. On your end, though, just please check Canvas and check email. Even if that email is not something you normally check, well, then guess what? It is now. I mean, because that's how the college communicates for the most part, right? And you don't want to miss if there's some grand announcement from the college. And that's how sometimes I'll communicate. Very often I'll duplicate. I'll send stuff over email and I'll put it in Canvas just so I try to hit as many people as I can. But just need to check things. And I am pretty good about checking things on my end.
A question, please. Do we have study guides for tests or quizzes?
So I have to think about, I have created practice tests in the past. I have them. And what I did last semester was I still gave the practice test out because then I have an answer key, but I did it before like a sequence of quizzes. So what I've done is my pre-calculus tests, I've cut each one up into basically 3 parts, and they each become a quiz instead. You guys with me?
Yeah.
And the reason I'm doing quizzes is because I think in this format, quizzes are just easier to manage instead of this big ass test. The final is just going to be our big ass test though, so just deal with that. So I'm still thinking about what to do with that. So I
Can we please have it, please?
I probably. Do me a favor. Send me an email and say, hey, don't forget to look at the practice test possibility, okay?
Oh, okay. Sure, of course.
Definitely. Thank you.
Even if you don't grade it.
What, sorry?
Even if you don't grade the practice test, just to know like where we're at with what the possibility of scoring in our next test would be awesome.
Well, I give the answer key out too.
Oh.
So then you can grade yourself. Now you're like, I'm not going to grade it the same way you would, Jeff, but don't do that to me. Don't suddenly make me grade things that aren't really graded. I've got enough to grade. So
is the practice scan just as a practice, or do we like have to do it? Worth points.
So you ready? It's not worth points, but you have to do it.
Okay, got it. Yeah, I turned it in. And then you fixed my mistakes. I'm like, oh, do I have to do it again?
No. So it's not.
Okay.
I gave you a problem to work, and even if you get that wrong, it's not that big of a deal. I just sort of put that out there to see where everybody kind of was. The answers to the first 2 questions I definitely want to know, but really the main thing of it is just to make sure that the app you picked is good. But I still want to know the answers to those 3 questions for sure.
All right, got it. Thanks.
I felt like if I made it worth points, that would sort of suck.
I have a question as well. For the homework, we can turn it in midnight, right? Correct?
I think off the top of my head, I think I made it 11:59. Is that right? Let me double check this.
Because I couldn't find it on the Canvas.
Hold on, let me see. Well, why is that?
It shows Saturday by 11:59 p.m. on the module.
There it is.
Okay, bet. Thank you.
I've got 8 p.m. Like, for example, I've got some times in there, but they don't show up for you?
No, for some reason it didn't show up. I probably need to update Canvas.
All right. Yeah, that would suck if the times don't show up.
Because I didn't do the practice scan thing, and I totally forgot, and I got off work like almost 5.
So look here real quick. Actually, I'm gonna look at this as a student just to make sure I know what I'm talking about. Here we go. In your to-do list, do you see how the times show up?
Okay. Yeah, I can see it.
Yeah. Okay. I like it. Yeah, people are leaving, which is fine. If you want to leave, class is over, so you don't have to stick around. But if you have a question, go ahead. Sorry.
I have a question about homework. So if we were to turn in our homework and we didn't receive a comment back, do we just assume that our homework was good, or would you say like, oh, your homework was good?
I try to say okay at the top if it was good. If I don't write anything at the top and I put complete, like your grade is complete, then you're fine.
Okay. Okay, thank you.
If the only time you have to worry is if the grade says incomplete. And by the way, everybody's still here. I always forget to say this. Don't just look at the grade you get. Look at the actual result, because I do put notes on those, right? So you have to, if you look at the actual file, you'll see all the notes that I put on there, and that'll help you study.
So if it says grade complete but no comments, we're just going to assume that our homework...
There's a separate place for comments. So let me see. If you actually go into the assignment and look at the assignment, look at what you turned in, you'll see all of my written notes.
Oh, go into the scan itself or the assignment?
Let me see. Again, you guys don't have to stick around if you don't want to, but I'm curious. I can't remember what it looks like from your end. Do I have something I could look at?
Because it says like submitted, it says the time, and then it says like grade : complete, and then it says comments, no comments.
But is it like a link you can click?
Only for my scan. It'll let me click.
Do it. Click it.
Okay.
Sorry, I didn't mean to shout at you. Do it. Click it. Yeah, I can't do that here. Shoot.
That just downloads the scan that I uploaded, though. It doesn't show like any comments or anything.
Is it something I actually graded?
I don't know. I've never.
So like if you're doing your practice scan, if you reviewed it, if you go to the module where it has the 0.2 practice scan, up at the right, it'll show your submission was submitted and the date submitted. Underneath that, it shows submission details. It'll pop up if you click on that, and there should be your file that you uploaded, and to the right of that, you'll see viewed feedback. If you click on the view feedback, it'll pop up in your screen and show what Jeff wrote on your paper.
Damn.
Oh, okay. I get that. Thank you.
You're welcome.
And that's my fault. To be honest, I don't think I've ever seen what it looks like. I've never had a student say they couldn't see what I was writing on there. So I wasn't even sure what it looked like on your end, to be honest. Maybe I'll play with that just to make sure I know what I'm talking about next time. But yeah, I don't always write in the little comment box. I don't like that as much. I like to write directly on next to the problems. It would so suck to say problem 3, you had this problem. No, I just want to write it right when it's happening. So yeah, you should be able to see what I wrote on graded assignments. All right, guys. I'll look more into that just so I know what I'm talking about from student, what it looks like on your end. Otherwise, I'll see you guys tomorrow. I think that's plenty.
Bet. Thank you, Professor.
All right, see you later, Professor.
Take care, guys. Bye.